So what we're doing today is a pretty straightforward, easy, quick lesson. All right. The What we're doing today, the learning target, I can convert an explicit formula to f of n notation. This is going to seem pretty silly because in the graphing calculator, you can just type it in like this. But occasionally, they will put something like this on the Regents exam in a multiple choice type question, and they will rewrite it into slope intercept form instead of being in this like arithmetic sequence form, all right, with the explicit formula. So it's important that you know how to change this explicit formula into f of n notation, all right? So the arithmetic ones and the geometric ones are done slightly differently. So it's very important that you're paying attention. So when we have an arithmetic formula like this, what you need to do, we have, first of all, we're starting off, our a sub n is at 3. So we're starting off the pattern at 3. And we are adding by 5 each time because that's our common difference. All that you need to do to make this arithmetic into an f of n notation is do the distributive property. So we're just going to take this 5 and multiply it by the n and multiply it by the -1. It's -1 because this is a -1. So all that we're going to have is 3 plus 5n minus 5, because 5 times -1 is -5. Now what you want to do is we could combine our like terms. We're going to add together our 3 and our -5. So we have 5n. We're just going to bring down that 5n. But now we're going to add together the 3 and the -5 to be a -2 or -2. We're going to write minus though because it's in the equation. So we have f of n equals 5n minus 2. So now we're just going to graph that. All right, so we're going to go to our y equals. We're going to type in 5x instead of n because we always use x on the graphing calculator, minus 2. And then just like yesterday, you're going to have to graph these. So we're going to go to the table. Remember that you ignore the 0 on the calculator. So these are our points. We have 1, 3. So 1 and 3, I'm going to put a dot there. 2 and 8, so I'm going to put a dot there. 3 and 13, so I'm going to put a dot there. 4 and 18, 5 and 23, 6 and 28, 7 and 33, 8 and 38, 9 and 43, and then 10 and 48. Now remember, all of these graphs are discrete. You do not connect any of the dots, all right? We just leave it like it is. Don't connect any of the dots. All of these graphs are discrete, so we just leave it like this. But again, the new part today, when you have an arithmetic sequence, all that you need to do is distribute, and then add together your like terms here. 3 plus -5 is a -2, but when we write it, we write -2. Make sure you bring down the 5n. So that's what we do for arithmetic ones. For geometric ones are a little bit weird, all right? Geometric ones are a little bit weird. What we want to do, so we have the g sub n equals 2 times 3 to the n minus 1 power. So we're starting our geometric sequence at 2, and we're multiplying by 3. 3 is our common ratio. We're multiplying by 3 each time. So what we want to do is we want to separate the power into 2 bases. So this is a little bit weird, all right? This is a little bit weird. All that we're going to do to get it into this notation, all right, because we want our answer to look like this. So what we want to do is just bring down this 2. You're just going to bring down that g sub 1. But now we're going to split this into 2 different things. So it says 3 to the n minus 1 power. We're going to split it to be 3 to the n and 3 to the -1. All right, we're going to split that off into 2 things. So we split it into 3. We split 3 to the n minus 1 power into 3 to the n and 3 to the -1. Now, what you're going to do now, before what we did with the arithmetic ones is we added these two together right here. We added together our like terms of 3 and -5. We added those like terms together in the arithmetic. What we're going to do here is a little bit different because we're multiplying all three of these things together. We're still going to combine our like terms, but when we combine our like terms, we are going to multiply right here. We're going to multiply our like terms together. So we're multiplying a 2 and a 3 to the -1 power. So we're just going to bring down our 3 to the n, but we want to multiply these two things together. So when I go to my calculator and I go 2 times 3 to the -1 power, I get this big long decimal. So I want this in the correct form. All right. I want this in the correct form. So this b to the n is really this 3 to the n. I need to put the a term. That's what we're figuring out now by multiplying these two things together. So I have 0.6 repeating times 3 to the n. That is my correct notation for an f of n in the geometric sequence. So I have it's normally a times b to the n power. This is my a. I got that by doing the 2 times 3 to the -1 power. And then I just brought down my 3n. So that's what we're actually going to graph. So 0.6666666. Remember, it's 6 repeating, so we got to type in a whole bunch of sixes. Or you could do 2 divided by 3, because that's really 2/3. Or you could do alpha y equals and do 2/3 times 3 to the n power, which is 3 to the x on the calculator. Second and table. So remember, we ignore the 0. We want to start off with a 1. So 1 is 2. Notice that our axis is going by 4,000. So you're not even going to see these first 4. So 1 is 2, 2 is 6, 3 is 18, 4 is 54. You're not even going to see the 5 on this one. The 6 may be slightly higher, but not much. 7 is 14, so that's a little bit under halfway. And then we have 4,300, that's just over the 4,000 for the 8. And then for 9, it's 13,000, which is right about there. And then 10 is 39,000, which is just under the 40,000. Remember, these are all discrete graphs, so you do not connect your dots. You just leave it exactly like it is. So notice that we have the geometric, we have that curve, all right? We have that exponential curve that's going on here. But this is it in the correct form. So again, what we do for arithmetic is we need to distribute, and then combine our like terms, adding them together. We just bring down the 5n. What we need to do, and notice that our 5n goes first and then our plus or minus, because we want it in this slope intercept form, which is this form. For our geometric, we take and we split our 3 to the n minus 1 to be 3 to the n and 3 to the -1. Then we multiply together our like terms at the end here, are just plain numbers. So 2 times 3 to the -1, that's where we get this 0.6 repeating. We just bring down that 3 to the n power. If you could go ahead and try this one, please. All right, this actually is number 2 on the homework today, but I want you to try this on your own right now, please. Go ahead and do this question. I'll give you about 30 more seconds or so. Most important thing, I think you know how to do the graphing. The most important thing is the beginning part, making it into that slope y-intercept form. So again, when it's in arithmetic sequence, all that you have to do is distribute and distribute. So 15 times n is 15n. 15 times -1 is -15. Just bring down our -50 and our plus sign. We want to add together our like terms. It's an arithmetic sequence, so we're adding those together. -50 plus -15 is -65. Bring down your 15n and stick it in front of it. So it's really 15n minus 65. And that is in the f of n notation. So when we go to graph it, we would type in 15x minus 65. Second in table. So 1 is -50. 2 is -35. 3 is -20. 4 is -5. 5 is +10. 6 is 25. 7 is 40. 8 is 55. 9 is 70. 10 is 85. Remember, we don't connect the dots. It is discrete. This is an arithmetic sequence. That's why it is forming a straight line. But again, what we wanted to do to make this into slope-intercept form is distribute and then add together our like terms. Go ahead and try this one, please. This is actually number 8 on the homework today. But go ahead and try this one, please. This is a geometric one. So on this one, what you're going to do is you are going to take this 3 to the n minus 1 power and split it into 2. So this becomes 3 to the n times 3 to the -1st. We need to bring down our -3 from the beginning and our time sign from the beginning. So because we're multiplying all of these together, you have to multiply these two terms together. Right? You have to multiply those two terms together. So -3 times 3 to the -1st power. So we would type into the calculator -3 times 3 caret button -1. When you do that, you get -1. So in f of n notation, we really have -1, that term goes first, times 3 to the n power. So when we go to graph it, we go to y equals, we type in -1 times 3 caret button x. Second in table. Now you'll notice that our numbers get really, really big, really, really quickly. So when we have 1 is -3. We're not even going to see it. 2, we're not even going to be able to see. 3, we can't tell the difference. 4, we can't tell the difference. Even 5 and 6, maybe a little tiny bit, but not much. 7 is 2,000. You're barely going to see that. That's a little bit under halfway. 8 is 6,500, so it's a little bit lower. 9 is 19,000, so 19,000 is right about in there. And then 10 is all the way down to 59,000. Notice that that is curving downward because it is that geometric sequence. But again, with the geometric, you have to multiply these two terms together. With the arithmetic ones, you have to add together your like terms.